Yeah, okay. So today we're going to go through the 2022 paper for AI2. If I've got my answers as a PDF here, um, I don't think I got them all right, but if anyone, yeah, please send your answers. If you have an answer that you would like to share, please do send it, because there is no mark scheme for this. There is for question two. Question two is has been reused in the tutorial exercises, so there is a mark scheme for those. But for the other ones there isn't. So please do send your answers, and I'll show them on the stream and everything. But yeah, I guess we'll start with question one. So basically, yeah, Mary's taking the exam, and there's 3 questions, and she basically either gets full marks on a question, or gets nothing. So question A has 20, B has 30, and C has 50 marks. So a total of 100 marks, and she basically, there's a certain probability that she'll get full marks. So with question A it's 60%, 0.6. With B it's 0.5, and with C it's 0.4. And they're all independent events. So yeah, and the question is the first question is, what is the probability she gets at least 70 marks? So please do send your answers, but I'll just go through mine, because I think I got it right. Because basically what I did is I looked at like all the possible probabilities, like the possible combinations of answers she could get. So she could get A, B, and C all wrong, or she could get them all right, or whatever, and then basically calculate like how many marks you'd get for each case. And then only these 3 cases have 70 marks or more. So that you add up the probabilities and get 0.32. Does that seem right? Why am I being pinged? Oh, it's not relevant. Yeah, I mean, that's basically what I forgot to explain. For these probabilities, because they're independent events, you can just multiply the probabilities here to get the combined probability, because they're independent. So this 0.08 would just be 0.4, because it's A equals 0, 0.5, no, 0.4 times 0.5 times 0.4 again, because C is correct. It's A equals 0, B equals 1, C equals 1. Yeah, and then, wait, can you hear me all right? Or, no, just you, sorry about that. Why did I divide the probability by the marks? Oh, I didn't divide it. I just, it's just bad notation. I just wrote a slash. It's not dividing. So this is 0.6 chance of getting 20 marks. It doesn't mean divide. I just wrote it badly. Yeah. So, right. Question B is, what's the expectation of the marks? So just the expected value. So we just multiply the probability by the number of marks for each question and add them up to to get 47. And judging by how Ollie did the same thing, I'm going to assume that's right. Yeah. Pretty simple. Question C. What? 1C was, yeah, you have these like 3 variables, so x1 to x3, and they each represent like the number of marks she gets for each question. And you have this main variable x, which is the maximum of the 3. So, yeah, which question did she get the most marks on? And then returns that number of marks. And then basically what is the probability mass function? It just says write down. I didn't really know how exactly you were meant to write. Oh god, wait, am I actually cutting out? I'm sorry, is this okay? Not sure. This is literally my reaction right now. Okay, I'll just keep going. Yeah, when it says write down the probability mass function, I wasn't really sure exactly like what kind of format they wanted it in, so I basically kind of figured out, okay, what are the possible values of x? And that's just depending on what question, depending on the value of x1, x2, x3. So she could either get like all of them 0, or get like 20 for A, 0 for B, and 50 for C. And then, yeah, you just take the maximum and it gives you this. And then, because these are the only possible values of x, this must be the mass function. It's, so like 1/8 of the cases are 0. Another 1/8 of the cases are 20. A quarter are 30, and half of them are 50. I also wrote down this range of all the possible values of x. I don't know if that's like part of the probability mass function, if that's like what they're looking for. But what do you guys think? Like, how, would you have written it differently, or do you think this is what they were looking for? Yeah, I can explain it again in a sec. Oh, sorry. Yeah, I'll just go through it all again. Yeah, I mean that's basically what I did, isn't it? Wait, or 40. Did I do it? I'm thinking. Yeah, it's like a mathematical function, so I don't think. Maybe I was wrong just writing what each possible outcome is. I mean, maybe this piecewise notation is what they were looking for. Although I'm not sure about 40. Is it? I don't think it's possible to get 40 marks. Is there? Yeah. How did you get 40? Maybe I'm missing something here. Yeah, I think I might have. Oh, okay. Oh, I see. Sorry, I thought I genuinely did something wrong. Or you. Oh, yeah. What were actually my problem? That was my answer, but that was. I see. That was the chance of failing all. Then the chance of 20 is. Because. Yeah, I'm not sure this. Okay. Yeah, I'll go through it all again because some people were a bit confused. So basically, the question is asking for the probability mass function of x, which is just a function which like you input one of the hold on, give me a sec. You input one of the possible values of x, and it outputs the probability of getting that value. So basically, it's like, what's the probability that she gets 0 marks? Or no, it's not that. What's the probability that the maximum mark on any question is 0, and that is only the case when she got all zeros, which is 1/8 of the time. Well, yeah, because all the possible values of x are 0, 20, 30, and 50, because each question gives 20, 30, and 50 marks respectively, but because 50 is the largest, if she gets 50, if she gets C right at all, that's gonna be the value of x. It's gonna be 50 because... Oh wait, I think I see where I went wrong now. I think I see what... Because, yes, the probability of each question is not the same. Yeah, I see. I was assuming that... I see, yeah, with this probability table, each of these cells is not equally likely. Of course. I thought I was oversimplifying this. Yeah. So it's actually, you would need to, what would you do? Hold on. You would have to, like, I'm going to look at your answer. Yeah, I guess you would just add up all the, you'd calculate the probability of that. Sorry if I say stuff and it doesn't make sense. I'm kind of just thinking out loud. Work out a function. What's with this? Anyway. Yes, that's basically it, yeah. It's what Whitty said. That's basically what the question is asking. Hold on. I might just start from scratch here. So this is, the probability of getting this one is 0.12 only. Yeah. Okay. Hold on, you know what, I need to draw on this, because I need to just... Yeah, that's 0.12. And so is this one. But then this one added up is... Oh yeah, I see, that's not quite right, because there is a higher chance of getting 30 as the maximum. Oh yeah, I should have posted the questions in chat, shouldn't I? Because I am kind of flicking through slides a lot here. I'll just do that. I'm sorry if this is a bit disorganized. It's mostly just 20 people watching me figure out how to do a question with help from everyone. Okay, yeah, cool. I'm just gonna try and... So, that would mean... Yeah, the chances of getting either of these cells would be just these added up. So, 0.36, if I'm not mistaken. If I'm wrong here, please tell me. Yeah, and then the rest of these is just these 4 added up, which, I'm just going to get my calculator because I can't be bothered. It's 0.4. 0.4. Yeah, so that's not that. It's 0.12. That's not that. That's also 0.12. That's not that. It's 0.36. Yeah. Okay. Let me just compare that to Ollie's answer, which is, hold on, the probability of, it's still not quite the same. Am I going wrong? Because I didn't get 0.18 for question, no, for B, for 20, I mean. Oh, there's an easier way. Okay, there probably is, to be honest. I'm always... Stop trying to react with a skull emoji. Okay. Wait, but the table is showing all the cases, and I am summing the probabilities. Maybe I'm not understanding, but if you want to like come up and speak, if you think you could explain it better than me, then go ahead. Get 30, you only care. Yeah, you have to get the second question right and fail the third. Oh, so actually, I guess you don't have to consider... Yeah. Oh yeah, so the probability of getting 50 is literally just the probability of getting C correct. Yeah, I see. Yeah, I'm so dumb. Right. And then the probability of getting 30 is just the probability of getting B correct, but not C. I think. Yeah, it's literally just the probability of getting B and not C, which is just 0.5. Yeah, that would be 0.5 times 0.6 times 0.4 times... No, yeah. That would just be these two added up, right? Oh, I've... It's because I've written these in a different order. That's why I was getting confused. It's point... Yes, that's 0.3, not 0.36. I was... Yeah, 0.18 plus 0.12. These are in a different order. Why did I write it that way? That makes so much sense now. I was so... So that is 0.18. Yeah, Ollie had it right. I thought Ollie was right. I was just so confused as to why I wasn't. I'm sorry about that. I was just being an idiot. Is everyone clear, or does anyone want to just go through it one last time? Yeah, okay, I'll go through it because it was a bit all over the place. So basically, question is asking, we need to write the probability mass function of x, which is the maximum of these three variables, and each of these is just the number of marks she gets from a question. So basically, it's a function. X is a variable which contains the number of marks from the question she got correct, which gave the most marks. And to get that, you can consider... hold on, I'm going to go back here. So you can basically consider all the cases... No, you don't actually know. I'll do it the simpler way. I'll go up to Ollie's message. This is what you do. So there's only 4 possible things that x could be. It could only be 0, 20, 30, or 50, because those are the those are the marks given by each question. And to get 0 as a maximum, you have to get all of them wrong, which is just this probability here. Hold on, I'll go. Which is all these three probabilities times together, 0.6 times 0.5 times 0.4. Oh, no, sorry. The other ones, 0.4 times... It's the same number, but the probability of not A times not B times not C. Then to get 20, you have to get question A correct, but nothing else. Because if you get something else, that's going to be higher, give you more marks. So A won't be the maximum. And the probability of that is 0.12. It's the same, I believe. Is it? No, it's not the same. I was reading. It's this row. It's 0.18. Yeah, 0.18. And then to get 30, you have to get the second question B. You have to get question B right, but get question C wrong. Because if you get question C right, then that will be the maximum, because it gives 50. But it doesn't matter if you get A right or wrong, because it's less than 30, so it will never be the maximum if you get B right. So the probability of getting 30 as the maximum is just the probability of getting B right and C wrong, regardless of A, which is just the chance of getting B right and A, which is this one here and this one here. I'm sorry I've written this out in a stupid way, but then you take these and add them up. So 0.18 plus 0.12 is 0.3 for that one. Probability X is 30. Then 50, to get 50 as the maximum, you just have to get C right, because it's the highest awarding question. So, and the probability of getting C right is already given to us. It's just 40%, 0.4. And that goes there. And yeah, you can, I don't think it matters how you write it. You can either write it like I have with the range here, or you can write it how Ollie did with the piecewise. Yeah, otherwise equals 0, because those are the only values. Yeah. Is that clear? I'm sorry, that was a bit long. What? Oh my god, that's amazing. Thank you so much. I'm not used to these like impromptu sessions. Yeah, this is the correct answer. Well, it's a bit messy, but I'll just leave it there for a second. Okay, I'll just continue. If that's all right. Cool. Right, question 2. This is the one that did have a mark scheme, but I'm gonna go through it anyway. But probably I'll be a bit quicker because the answers are actually there. But basically, this is just a bunch of yapping. All you need is this bit, really. That's not relevant. It's just explain what mutual information is. When I did this question, this was in the exercise from week 4, yeah, week 4 exercise questions. And when I was doing this, I'd recently done that worksheet, and I'd like sort of remembered the mark scheme, sort of. And the key thing they want you to say, I think, is like, well, it says it here, obviously. It quantifies how much knowing about one variable reduces uncertainty about the other. Whenever they ask about mutual information, I've noticed they always say this. So I'm guessing if you put this in the exam, you'll definitely get a mark. Strong dependence. Yeah, so the way I wrote it was basically it measures how mutual information of two random events measures how dependent one event is on the other in terms of like the probability. So I didn't write this, maybe I should have, but if mutual information is 0, the events are independent, and other than that, when the mutual information increases, the amount they depend on each other increases. And yeah, that basically means if they're dependent on each other, if we know about one variable somehow, then it means we know something about the other one because it depends on it. So it reduces the uncertainty, if that makes sense. Information gain and mutual information. I think they're the same thing. I'm pretty sure information gain is just a term used in decision trees, and mutual information is just the like official term. I doubt you'd get marked down for saying information gain instead of mutual information. That would be pretty mean if they did that. Yeah. Mutual information gain is not symmetric, but... Wait, information gain is not symmetric, but mutual information is. Is that right? Reduction in entropy. I mean, yeah, that's all mutual information is the... It's sort of like the difference in entropy between... There was some formula... Well, there are formulas linking mutual information with entropy. I've just forgotten them. But they're not needed here. You just explain what it is according to the solution here. Yeah, that would be it. Yeah, I think I'm like 90% sure they're the same. Is that question clear with everyone? Yeah, I'm just gonna wait for people because I think there might be a few more questions. Okay, maybe not. I don't know. I'm just gonna I'm just gonna go on to this one. Yeah, so we have this algorithm which it's feature selection. So it's basically selecting a set of features to use in a decision tree, I think, for like splitting the data into classes. It's like basically finds which features split this data the best. That's what I get from it. And it asks you to explain lines 4 to 7. So what is this loop doing? And they give a long answer. I haven't read this yet. I'm just going to go through my own answer because I understand it better. And I think I got it right. I got it right. I sort of remembered what they said in this answer, but not much of it. Anyway, so the first line of it finds the feature from the set of remaining features. So this is the features we haven't picked yet. It finds the feature which maximizes mutual information with the target variable, which is the class. Basically, we find the feature which is like most similar to the class variable. So which feature is most kind of like dependent on it. Or it's kind of like the other way around. Which feature does the class variable depend on the most? Which allows us to find the best one to split it on. And then also, because that's the maximizing bit here, so we're maximizing this. But then, we're maximizing the current variable we want to select with the class variable, which is like which class the data's going to. And then we're maximizing this, but because we're minusing this, we are minimizing it, I think. I think that's right. So basically, it maximizes the mutual information with the target variable, but it minimizes what they call redundancy. I remembered this word from the mark scheme. They specifically say minimal redundancy. And that what that means is it minimizes redundancy with the variables or features. I said variable, meant to be features which we've already chosen. So it minimizes the information, mutual information of this current feature with the ones that have already been chosen in previous iterations of this loop. So, and basically what that means is that it means like, what that means is we avoid choosing two features that are really similar to each other, that are like dependent on each other. Because if you have two features that are basically the same on like a decision tree, that's kind of pointless. You're like splitting... Oh, shut up. No, oh my god. Sorry, stupid WhatsApp. No, how do you... I don't know how to close WhatsApp. Whatever. What was I saying? Yeah, you don't want two features in your final set S which are like dependent on each other. In other words, you don't want two features with high mutual information, because I've forgotten exactly why, but you don't want it. And by minimizing this, we are basically minimizing how similar this new feature is with all the ones we've already chosen. But we're also maximizing how similar it is to the class variable. Yeah, sorry, that was a bit of yapping. I'll just leave this on screen for a bit longer because I haven't given people a bit of an actual chance to read it. But then there's also the second line, which it just removes the feature we chose from the set of remaining features and adds it to the set of chosen features. And then the loop just repeats until we have k features. So that's what this says. It just says until the size of the set S is k, or the cardinality is just the number of elements in S, which is the set of features we've chosen. So yeah, repeating until there's k features. And then this bit just says set F to be itself but without F max, because we just chose that, and this is the set of ones we haven't chosen yet. And then set the features of the set of features we have chosen to be itself plus F max, because we've now chosen it. Does that make sense? I know I went on a lot there, but I feel like my answer is quite good. I can show the mark scheme answer if you like, but I'm pretty sure it's basically the same. I don't know, I'm sounding a bit arrogant there, aren't I? I'll show the mark scheme answer in a second. I'm just going to look at what other people have put. So I haven't... Yeah, waste of time, I guess, yeah. Anyway. Oh yeah, this was in the, there was a question in the other paper which was about the, I think it's in the 2023 paper, I did it last night. I didn't get a very good mark on that question about why is having multiple features that are dependent, why is that bad? This must be... Is this the mark scheme answer? Or is this your own answer? I'll read it anyway, because, yeah, it's slower. That's the only thing I could think of, really, is that if you have more features that are unnecessary, it's, like, slower to calculate. But, yeah, I'm guessing it... Yeah, it won't generalize as well, so the model just isn't as good. Fitted model, hard to interpret, because there's too many features. Oh, and the rest is... Yeah, okay. Oh, the beta... I don't know. I don't really know what it is, I'm gonna be honest. I can't... Yeah, I think it's some sort of learning rate. Because it kind of just multiplies the amount that we don't want our feature to be similar to the existing features. So... But I can't think what else it could be. And I don't know if we have to talk about it. I'll have a look in the mark scheme. Yeah, I see. Yeah, it's the minusing bit which does the redundancy bit, yeah. And, yeah, okay, yeah, I thought beta was just, yeah, some coefficient we can just set depending on how our model is. I'll just have a look at the mark scheme answer, because this is the definitive answer. Yeah, so they're used to select features. I probably should have explicitly said that in my answer, like, what is it, the algorithm actually for? Yeah, it selects k features. Yeah, we find the feature which maximizes mutual information among... Oh yeah, so the feature from the set F which maximizes mutual information, well, with the class variable. It doesn't say that here, but yeah, mutual information with the class variable. Some features may be highly correlated with each other. Yeah, so selecting them would be bad because it would increase the number of features without improving the prediction. Yes, this is exactly what redundancy is. You're like using more features for no benefit, so you don't want to do that. So then, yeah, we can minimize redundancy between the feature we're currently looking at to see if it's the maximum with the class variable xi and the set of already selected features. Yeah, minimal redundancy. And that's what the second term here is doing. Interestingly, they don't have a beta symbol here, but so I guess it doesn't matter if we mention it or not. Yeah, and then add it to the set S, which is what this does, and remove it from F, which is what this does, and then repeat until we have K. We got K. What weird. Yeah, iterates to select the K best features. Whole algorithm. Okay, we don't need to... That's not even required. Right. Okay, is that all clear about that question? Oh yeah, K I think is just some value that you choose for like how many features you want. Because yeah, we don't... Or do we not... I'm not sure what you would actually do about choosing K. Like, do you actually choose it, or is it a thing which you calculate? but I'm pretty sure you're meant to know what k is before running this algorithm, if I'm not mistaken. Or, yeah, I'll just... wait for a second opinion on this, because I might be wrong. Yeah, I see. Yeah, that is what I was thinking. It's kind of like, yeah, K and N, that's a good example. Like, you know what K is. Yeah, anyway. That's the wrong thing. Okay, this one... Yeah, this question was in the week 5 exercise sheet, because it's about Bayesian networks. This is yapping. Basically, you just have 4 kind of features of the data and 3 kind of class variables, but basically these are all just variables, and then they are connected in a Bayesian network like this, like it says here. So F1 only depends on A1, F2 depends on both A1 and A2, F3 depends on both A1 and A3, and F4 depends on A3 only. Yeah, and they can be either true or false. And yeah, it just says draw the network. So this is the network that they gave. Oh wait, I'm sorry, I'm not sending screenshots of the questions. I need to do that. Let me just quickly do that because... oh my god, I'm being called. Shut up. Right. Anyway. I'll just quickly send the screenshots because... bro's tweaking. Yep, sorry, I'm like... stupid. Literally, I did not expect there to be like 20 people, so I'm kind of like a bit on edge. I just thought there'd be like 3 people. Whatever. And it's being recorded. Whatever. Yeah, anyway, what was I saying? There's the network, if you want to compare it to yours. Yeah. Phew, I need to stop stressing. It's like, yeah. And that's what I drew, which is basically the same. Yeah. And this question is just write down the joint probability distribution, which I believe is, well, it has the answer here. It's just like the probability of all of these happening. I don't really get what this is meant to represent, but I get the formula is just you take every node and multiply it by its parents. Is this wrong? Wait, there's one there. Is that... oh no, wait, no, I'm just being an idiot. Yeah, that's fine. Sorry. Yeah, no, you take each node and just multiply it by... no, you don't multiply it. You, given that, you do a conditional on its parents, because it can only happen given that its parents have happened. Yeah, and then you just multiply all of them for each node, and it gives you this. Yeah. No more questions, right? Oh my god. Oh yeah, I hope I'm not exposing too much of my computer. How many parameters required to describe this distribution? I wasn't entirely sure what to do for this question. I'd forgotten. I don't really get what it means when it says number of parameters, so please do post your answers, or like what you think of it, if you think you know better than me, because you probably do. Like, what does it mean by the number of parameters in the problem? Because I can see these are definitely different values than I got. Because I can see how this is 1 and this is 2, because there's 2 variables here, but there's 3 here, so I don't really get why it's 4. Like, because, yeah, I mean, because I did it wrong. I put 3 in, got 13, when it's actually 15, because you have 4 instead of 3 for these. Oh, that's actually so simple. 2 to the power of number of parents. Okay, that... yeah. What's this question? Number of terms... Wait. Oh, like... Oh, yeah, I see, because it's, like, deceptively simple. Yeah, it's like... It looks... Look, what I mean... No, it gives a lot of marks for what it is. Yeah, I don't really get that either. It's just simple addition, really. I guess... There was another question which gave, like, 8 marks for, like, 1 Minimax node or something. It's crazy. Yeah, I think that literally what Hazard's saying, you just show the working and you get 5 marks. Yeah. But, yeah, the key is just knowing the number of parameters, which... Okay, I'll definitely remember this. 2 to the power of the parents, the number of parents. That's actually so much easier. Right. Question 4, sort of. It's... Oh, yeah, I wasn't entirely sure for this one either. But, so if we observe that F2 is true, what does observing F4 is true tell us? So, here, if we observe this, what happens if we observe this as well? Like, do we learn anything? Because what I put is that... What did I put? From observing F2, we can only infer about A1 and A2, because that's what caused it. So if we learn about F4 as well, then we learn about A3. But I don't think that's actually what they're looking for in the answer. Where's the answer? Because it says still only gives us information about A3. If anyone understands this question better, please send your answer or something, because I wasn't entirely sure on this one. Oh, sorry, am I interrupting something? I don't know. But, yeah, I mean, I sort of put that. It was... So, with F2 equals 1, observing F4 equals 1 still gives us information only about A3. I don't get that. Surely observing F4 as 1 always just gives you information about A3. Surely observing this will never tell you anything about these two. So I don't get why it says, like, still here, because it's still only... No, it would always be only A3, right? Wait, does anyone have anything to say about this? Like... I'll go on to the second bit, which is, if we observe F2 is true, and then observe F3 is true... Oh, no, sorry, that's wrong. If we observe F3 instead of F2, so if we instead observe F3 true first, then F4 true, does F4 actually tell us anything? Then I don't get this answer. It says here, if we observe F4, then F4 will give us information about A1 and A3. But that's what F3 already gives us information about. So, I think I might not be getting this right, but because what did I put here? I said that, yeah, learning F4 is true tells us nothing because we already know about A3. But I think that's definitely wrong. I'm just gonna see what you guys have put for this because I wasn't sure, of course. Right. I see. I think I see. Because, like, if you know that F3 is true, then do you know, like, more about F4 because it's also got the same parent? I guess. I don't know. It doesn't seem like that's what the answer was saying. What does it say? Like, is this information about A3? Because that's. Yeah. Um, I'm not sure. Maybe we will just move on from this. Because, I mean, this was. I forgot if there was another session on this worksheet. Um, but there might have been. So I might just be covering stuff that was already done. I don't know. Yeah. What am I doing? Sorry. First statement. So, sorry, where was it? So if F2 is true, then observing F4 is true. The answer is observing F4 will just give information about A3. I'm not entirely sure why it says still only A3, because I think I would have thought F4 always gives you information about A3, no matter what you've previously observed here, but I might be understanding that wrong. Yeah, we already knew that. Do you mean what I just said, or do you mean like observing F4 after F2 means you already know? Oh, hello, sorry, yeah, hi, I can. No, that's fine. Yeah, I'm just yapping anyway. Oh, oh yeah, I think. Let's see. Yeah, sorry. Yeah, I think that's what it's trying to say. I think that's why it says still. Because I think no matter what you observe before, F4 will always only tell you the same thing. And yeah. Yeah, it actually doesn't. I guess. Wait, no. Oh, No, but it wouldn't become dependent on anything else. You're learning. If you find out that f4 is 1, then you are learning like that a3 is more likely to be 1. Right? Like, I guess it doesn't. Yeah, you were right. Yeah, I think you were right there. It doesn't have any relation at all. But no, I think because they wanted us to point that out, that it doesn't matter, that nothing special comes from observing f4 if we observe f2. Well, I think, because like, but if I think the idea, I think with f3, if we observe f3 then f4, then I think that gives us more. I mean, yeah, that's what I was thinking. Because like with f3, you already know about a3, and then it's just telling you, oh, a3 again. Like, wow, we already knew that. I don't know. It's so weird that this is literally. Hold on. Yeah, I mean, that's what I would have thought, right? But it doesn't. According to this, it doesn't. I don't know. Yeah, yeah. That's common cause. Oh, I see. Competing causes. I don't. I guess so. Yeah. Yeah. Okay. Cool. Um. Right. Sorry, that was a bit long. Uh, I'm gonna move on to question 3 now. Which is a minimax question. So, yeah, and they use this tree, which basically, yeah, these are max nodes, these are min. So this is trying to maximize it, the value, and these are minimizing it. And they use this notation. So this would be like L1 dash 1. This one here would be L3 dash 3 because we go L3 then 1 2 3. Yeah, and then it asks you. Sorry, I'm scrolling all over the place. It says give the minimax value of the root node and the two nodes at the second layer. So, yeah, no alpha beta pruning or anything. This is what I got. I just worked my way up from the bottom. Ignore these alpha beta values. That was for the next question. But yeah, because this one would be 8 because you're minimizing these two values. Then this one would be 13. And then this one would also be 13 because it's bigger than 11. This one would be 12 though because that's bigger than 8. But this would be 12 because it's the smallest. Then over here, you've got 7 would be the smallest. Then 9 would be the biggest. Then 4 and 14. But then these are the important values. You just have to do all this to get these. And this would be 12, this would be 9, and this would also be 12, because that's the biggest of those two. Yeah. Basically, it's pretty obvious stuff I just explained. But yeah, if anyone got a different answer, if I'm missing something really obvious, do let me know. But yeah, that's that. As for the alpha beta pruning, there's quite a lot of things I found that were pruned. I think I did this right. Not. entirely sure. I'm not that good at alpha beta pruning, but I think I might like go through it again. Does anyone want me to go through the alpha beta pruning like from the start? Just to, because I'll go back to my answer, but this is what I got. I got that you'd basically go down here and find that you'd find that 8 is less than 12 here, and basically that means that Max would never pick this branch up here because it's always going to be 8 or less, because Min will always pick 8 or less now that it's found 8. So basically beta becomes less than alpha here, so you wouldn't explore 15, you would just go straight back up. The same thing here, you've already found 12, and then Min, this would be 13, or this one here would be 13 or less, which causes this one to be 13. But then we know that Min won't pick this because it's bigger than 12, and Min always picks the smallest, so we don't explore here or here. Is this that website? Yes, I've been using this website. It's great for practice. I could actually show the solution on here for this question, if you like, because it's quite good at visualizing it. I'll just go through it on here though. Then down here you find that this would be 7, which becomes less than beta again, so you don't explore here. Then up here that you find this is 9, and because Max picks the maximum here. But then that means Min will choose 9 or less here. It doesn't matter what this is. It will have to be less than 9 if it will be picked. But that doesn't matter anyway, because Max will always pick this one because it's 12. It's not going to pick this if it's 9 or less. So you can forget about this whole bit. Prune all of this because this is 9. If that makes sense. I might actually, although I don't know if you can actually type this tree into this, because it has a fixed branching factor. Like, you can't change the, because this tree has like a branching factor of 3 here and a branching factor of 2 here. So I mean, this one wasn't pruned anyway, so we could try just doing it without this branch, maybe? What would that be? That would be a branching 2 ways of 1, 2, 3. Although I don't think you can have nodes like this. I don't think you can simulate it on this website. But oh well. Does my answer look okay? If anyone has a different answer, please, or even if you have the same answer, please do post it. Yeah. No, I think I'll just move on. Yeah, that was 10 marks for listing all those. And then this one, oh yeah, this is the thing we didn't have to know, but I thought it was kind of interesting anyway. We don't have to know this, it turns out, but these nodes just pick at random, so it's like 50-50 which node it will choose, and I figured that the value would be like the mean, maybe? I don't know, I'm probably wrong with this, but I did it anyway, and I assumed like, okay, so the average value here is going to be 8 plus 12 over 2, which is 10. and that gives you these values, but I don't know, it could be a different thing. And then for this one, which we also don't have to know because it's to do with the chance nodes again. I said that you couldn't prune it because to prune a branch you have to be absolutely sure that its parent won't be visited. So, like with this one here, we know that once we know that this is 9, we know that this is always going to be 9 or less. So Max will never visit this. We know. So that means we can prune this. We can only prune this once its parent, we know that it will never be visited. But the problem here, I thought, was that we can't be sure that it will never visit this because it's always 50-50. Like it could always visit this node or this one or whatever nodes below the chance ones. You can never be sure if they're going to be visited or not. So I feel like you couldn't prune it because it's random. I don't know, does that make sense? Or, yeah, you're right, you might just have to... Oh, is that regarding like the mean thing I did, where it was like 8 plus 12 over 2? You could assume the worst, I guess, but it's weird because they're not min or max nodes. So, because if you just assumed the worst, that would be min. Yeah, I don't know, but we don't have to know it. Yeah, but no, that's all really, because we don't have to know chance nodes. But is there any other questions about this paper? I'm sorry it was a bit of a slapdash session, but I hope I explained things well. If you want me to do the full alpha beta pruning, I can. Okay, no problem. Yeah, okay, we can go over that. Yeah, thanks for tuning in. I'll just do questions now, but wait, oh yeah. What was it? The probability mass function. So the probability that the maximum mark is a certain value, I guess. Yeah. I guess I'll just talk about it again. So, yeah, you have these 3 variables which just represent the marks she gets for A, then the marks she gets for B, and the marks she gets for C. And these are either... this is either 0 or 20, this is either 0 or 30, and this is either 0 or 50. And so this would be 20 with probability 0.6, because there's a 0.6% 0.6 probability that she gets question A right. So that means there's a 0.6 probability that this has 20 marks. And that's the same for both of these with 30 and 50. And then basically this x without a number is just the maximum of whatever these are. So it's just which question did she get right that gave her the most marks. Because, yeah, and basically we need to work out like what is the distribution of x. So what's the probability of getting like each possible value. So the possible values for x are each possible mark for a question that she could get. So it would be 0, 20, 30 or 50. Those are the possible maximum values for this. Because if they're all 0, then the maximum is going to be 0. But the only case where it is 0, hold on, let me go back to this because this is the actual corrected answer. The The only case where they're all 0 is when all 3 questions are answered wrong, which is, and because all questions are independent events, you multiply the probabilities. So to get them all wrong, that would be 0.4, because that's the probability of getting it right. 0.4 times 0.5 times 0.6, which is 0.12, 0.12, yeah. And then the probability of getting 20 as the maximum, oh, I didn't mean to draw, is, it's just, the only case where 20 is going to be the maximum is where we get question, where's the bloody, sorry, I'm lost, there we go. Where we get question B right, no, question A right, but no other questions right. Because if we got one of these right, then they would be the maximum. So question A, the only case where X will be 20 is where we get question A right and nothing else right, which is basically the probability of getting A right times the probability of getting this wrong and then this wrong. So, sorry, it would be 0.6 times 0.5 times 0.6, so 1 minus the probability of getting it right, which is 0.18. Oh, that is wrong. Let me just write 0.18 there. Yeah, 0.18. Yeah, so that's for 20. Then for 30, there's 2 cases. You can either get, well, no, there's 2 cases, but they're easy to get. Basically, all it means is that to get 30 as the maximum, you have to get B right, but you have to get C wrong, because if you got C right, then that would be the maximum. So, and X wouldn't be 50. It wouldn't be 30. It would be 50. But if you get B right, the maximum will be 30, no matter what you do with A. Because if you get A and B right, B is going to be the maximum because it gives more marks. So basically, yeah, you just take the probability of getting B right and A wrong and add to the probability of getting B right and A right, which is these two, be this probability plus this one. Sorry for how badly I've laid this out, but basically, yeah, so, but the key is that C has to be wrong, and then if you add these up, you get 0.3. Yeah, and then to get 50 as the max, to get 50 as the max, you just have to get C right. Which, because, yeah, getting C right is automatically the biggest, because it gives the biggest number of marks. And, yeah, the probability of getting C right is just 0.4. And then the answer they're looking for, they just ask for the probability mass function. You just give what is the probability of getting each value of X. So these are the 4 probabilities. And then you list what are the possible values of X, which is this. Does that make sense? Max from the distribution. I'm not sure how this relates to estimation. It probably does in some way. Like MLE, MAP, I've just kind of forgotten. Sorry. Yeah, I can post the PDF of these solutions. I'll put it in recaps, I guess. Yeah. Yeah, no problem. I know it takes a long time to explain because there's a lot of bits. I just really like to go, as much in detail as possible. Thanks for all coming. That's probably all, unless there's any other specific questions, but yeah, that's amazing. Thank you. I'm going to stop recording.